Okay, an expression equivalent to this. Now, this was on the cards, but it didn't fall into any of the categories of a multiplication problem or a addition subtraction problem or even a solve for x problem. It's just a factoring problem. And what we want to do is see if we can take something out of here. Chances are you look down at the bottom, there's no fractions, which means this evenly goes into the numerator, which is kind of crazy. So that might help you if you look around and see that. So you can take out a 5xy, and we're left with, well, the 5's gone, one of the x's is gone, and the y is gone. That leaves me with an x squared. 5's gone, that gives me a 4, and the x and the y are reduced by a single x and y. And you can take out another, yeah. Okay, so you can take out a 5 from here, you're left with a 4. The x is gone, but you still have a y squared. Okay, so you can cancel that and that, and we're down to this. So something's got to involve a y value, so that means we can get rid of this guy. The fact that there's a 2 here and a 1 there basically means this one can't be our factor. And so if it's a plus and a plus, you really, the y value is sort of kind of getting in the way maybe for some of y'all. But the question becomes is, well, this here is a term that's basically missing the middle term, right? This is a term that is yet to be factored. So this can't be the case because there's still a middle term there. This, if you FOIL this thing out, becomes that. I guess that's the best way to explain that one. So there you have that. Again, another situation where basically you can, you got a common denominator here. It's x plus 5. This is over 1, so if I multiply by x plus 5, all three of them, especially the middle, x plus 5, don't forget it's a negative 6, that cancels. I'm left with a 3 here. Move this over. This does not cancel, so I have a minus 6 times x plus 5, and we'll perform that operation shortly. These also cancel, so I'm left with it equal to a 3x. Okay, so distribute the 6 to both, becomes a 3 minus 6x minus 30, okay, equals 3x. Well, if I add the 6x to both sides and combine these guys, I end up with a negative 27 equals positive 9x. Divide both sides by 9, you get x equals negative 3. Well, that seems all well and good. There's no solution here, so something to think about. If you plug that in, will you wipe out either of these denominators? And the answer is no. So your answer there should just be the answer A in this problem.